Hi, everyone. So today we're going to get started on our unit on statistics. This first lesson is very introductory. It's a lot of vocabulary, pretty intro level. There's kind of one math concept that we'll have to talk about, but shouldn't be too bad overall. For those of you who are currently in AP Stats, this is going to be a lot of review of some of the very, very earliest stuff that you did. So you should be able to fly right through this. So we're going to start out with a bunch of vocabulary, and I'm going to talk through these things. If you need to pause the video to be able to copy down definitions, please feel free to do so. So first off, what do we mean when we're talking about statistics? Statistics is a specific branch of math that deals with collection, analysis, and interpretation of data. And that's kind of the three areas that statistics focuses on. Is first we have to think about how do we collect data appropriately, and then how do we analyze? That's where the math comes in. How do we make projections with it? And then interpretation is how do you spit it back out? How do you say to someone, this is what this data really means? Okay. So some of the things that we have to be concerned about as we're starting to do this process of collecting, analyzing, and interpreting, we need to think of what our variable is. And you're familiar with the concept of variable in algebra. In statistics, the variable is referring to whatever the thing is that you're studying. Okay, so the characteristic of the person or thing being studied. The population is the entire group of people or objects or whatever it happens to be that you're studying. So if I wanted some data about students at Jenison High School, the entire student body of Jenison High School would be the population. Okay, if I wanted data about the state of Michigan, all of the residents of the state of Michigan would be my population. But it's typically not feasible to actually study the entire population. So a lot of the times we do what's called a sample, where we take a small group of objects out of the population, we study them, and then we project that data back out onto the entire population. But choosing that sample, we have to be really, really careful about, and that's where this concept of the collection of data becomes important. We have to make sure we're choosing a sample that truly represents our population. So we'll get more into that later in the year or next year in AP Stats. You're going to talk about lots of different ways to find samples. So this first example technically is a statistic situation. It's not what we usually think of when we think stats, but it says a physician takes a biopsy of a suspicious growth to check for malignancy. Identify each of the following. Okay, so a biopsy is when you cut off a little piece of something to go study it and make some assessments about the entire growth. Okay, so the variable that we're studying here, the thing that we're trying to find out is whether or not this growth is malignant. So our variable is the malignancy. And I'm going to put it with a question mark, like that's what we're trying to find out is this malignant or not? This is like a yes or no question. Okay. The population then would be the entire growth. So all of the cells in the growth would be the population. And the sample would be just the little piece you cut off as part of the biopsy. So we are going to take a biopsy. We're going to study that biopsy. If the cells in that biopsy are malignant, that will answer our question about the entire growth. That will say that the entire growth is malignant. That's the purpose of a biopsy. So that was just to get you kind of used to using those words here. Okay, a couple more words for you. Survey. Survey is a method of collecting data. You've all taken surveys before. When we're doing statistics that we want to actually do some, in-depth analysis on, we have to be really careful about how we construct our surveys. And then the next word here is random selection. This word random, we throw that word around a lot, right? In just everyday language, but in math, random is a very specific term. Random means that every member of the population is equally likely to be chosen. And remember we talked about the sample and making sure you get a good sample that's representative of your population. The way you do that is by making it a random sample. Okay, if you make it a random sample, that means that you're getting good representation from everybody that population is supposed to represent. Okay, so for example, if I say that I want data about Jenison High School and my sample is going to be Mrs. Charigno's 5th hour class, let's say, that is not a random selection because not every student in the school has an equally likely chance of being chosen to be part of that sample. And so what that means is that sample is not going to do a good job of representing the entire school. Okay? Okay, so let's go on. This next page, I'm not going to spend a whole lot of time on this because I think you've talked about this, but this first section gets into two very basic types of data displays, the bar graph and the circle graph. Really, I just want you to understand when do we use one or the other. So bar graphs can be used with numerical data. I mean, one of the variables has to be numerical, right? But the nice thing about bar graphs is one of the variables can be what's called categorical. And that's not a word that you have to know, but categorical means that it's not necessarily numbers. So like down here, we've got ketchup, peanut butter, chocolate bar. Honestly, I don't know. Oh, this is amount of sugar in certain foods. So bar graphs work well when your things down here, when one of your variables is not numbers. Okay, you can divide things into categories using a bar graph. A circle graph is really helpful anytime you're looking at parts of a whole. So this particular circle graph is talking about like your final grade. And so we know this circle represents the final grade, and then the individual pie pieces are like the parts of your grade. So anytime you're looking at comparison to the whole or parts of a whole, circle graphs are a good way to go. So we're going to do some math in a minute that shows you how to create a circle graph. And we'll get more into that then. I think that's my next example. Yep. Okay. And as far as this example goes, this is the only real math in this lesson. The goal here is to construct a circle graph. I don't know that you will ever in your life have to truly create a circle graph entirely by hand. Like I'm talking protractors and making sure the angles are measured correctly. We have software to do that for us now. But I do want you to understand how these numbers here translate into these different pie slices. So we're going to talk about the math, but then as far as the drawing goes, we're going to do a lot of estimating. Okay? So we are looking at the different continents and their land areas, and we're focused, I know it gives us population and land area, so we could do some like population density and stuff like that, but we're just focused on the areas right now. So to construct a circle graph, what I really need to do is I need to be thinking in terms of percentages. So I need to find the total area here. So I'm going to add all of these numbers together. And what I think I'm going to do, let's see, this one has a 200 at the end, but otherwise they all have all zeros. So just watch what I'm going to do here. And you could type it in with all the zeros. I'm just going to type it in without those zeros at the end. So notice I'm cutting off the 3 digits at the end of everyone. I'll deal with that 200 in just a minute, because this is going to be a really big number anyway. So my total here is 57,708,000, and then I need to fill these in. I know that if I added together these last 3 digits, the only thing I have sitting here is this 200, so I know I'm going to have a 200 down here at the end. Okay. And now what I want to do is take each one of these individual values and convert it to a percentage by dividing it by the total. Okay. So I'm going to do 11,730,000 divided by 57,708. And that's about 20-ish%. Okay. Now I'm going to do, this is, you know what, let me show you a calculator trick here real quick. This might make your life a little bit easier. So you probably didn't know you could do this on a calculator. I'm going to take that number, because I'm going to have to type this number in over and over again. So here's what I'm going to do. I'm going to go 57,708,200. And I'm going to hit this button down here that says store, S-T-O. That's going to let me store this for a value of X. So I'm going to hit store, and then I'm going to push X and hit enter. Okay, now it looks like it didn't do anything, but now watch what happens. if I push the X button and just hit enter, now it tells me that X is equal to this value. And that means when I go to do this next one, 5,300,000, I can just say divided by X instead of having to type that number every time. So that's like a 9%. I'm moving the decimal point over 2 because it's a decimal. 16,920,000 divided by X is about 29%. Okay. 3,930,000 divided by X is, that would be 6.8%. I'm gonna call that a 7% because I'm just going to whole numbers here. 9,460,000 divided by X, 16%. 3,478,200 divided by X, that's a 6%. And 6,890,000 divided by X. I'm going to call that one a 12%. Okay, and if I added all of these percentages together, they should add up to 100% or close. I did round them, so I can't guarantee that it's going to be exactly 100%, but pretty darn close. Okay, so now to actually put it on the circle, I mean, some of you might just be able to estimate based on the percentages, but estimating what 9% of a circle looks like is going to be tough. But we know that a circle is 360 degrees, right? So what I'm going to do is I'm going to take those percentages and convert them to degrees, and then I'm going to sketch those angles inside the circle. So, for example, I'm going to do 0.20 for the 20% times 360. Okay, and then I'm going to do 0.09 for the 9% times 360. Now, what I guess I could have done, and I didn't want to throw all of this in at one time, but when I was doing those calculations a minute ago, like I could have done this division and then just immediately hit times 360, and that would have immediately given me an angle measure. So I could have been doing this at the same time. I don't know that you necessarily need to take the time to write this all out again. I'm going to do it just so that you have it in front of you for your notes, but I'm just writing down. Okay, and just so you know, normally if we were in class doing this, I would have you guys doing all of this, number crunching here. So I apologize that you have to sit and watch me type all this stuff on my calculator, but if we were in class, we would totally be dividing and conquering here. So I'm going to do 0.20 times 360. And so this becomes a 72 degree angle. 0.09 times, 360 is about a 32 degree angle. 0.29. Since we're just going to be visually, kind of estimating these, I'm okay with the rounding here. I'm going to round that down, I think, just because I've rounded a bunch of these up already. I'll break my own rule. I'm going to round that one up to balance with the one I just rounded down. Okay, and so in a perfect world, those degrees would add up to 360. Okay, they probably won't because we rounded these decimals and then we rounded again here. So we're probably a bit off from 360. But what I would do here is I would just start from the center and I would draw a line, and this first line can kind of go anywhere. Okay, but now I want to draw approximately a 72 degree angle. So to visualize that, I know what a 90 looks like, right? A 45 would be half of that. So 72 might be something like this. Okay, ish. And so there's my 72 degree angle, and this would be Africa. So then starting from that line, I want to visualize about a 32 degree angle. Well, 72 and 32 together make 104 degrees. So I know that from my original line, I've got to be more than 90 by just a little. So I'm going to go like, I don't know, maybe there. although those look very similar to each other. I think this one actually needed to be a little bigger. I think my 72 needed to be larger. We'll go like that for 72. This 32-degree angle, this one is Antarctica. Now you'll notice this next one is 104, which is really the same as this. So I might even, there's nothing saying that these all have to be across from each, or that they all have to go in order, you know? So what I'm going to do is I'm going to make this line go straight this way, and this line go straight this way. And that means that this should give me 104 degrees because now these two things are vertical angles. So throwing some geometry in there at you. And so my 104 degrees, that would have come from Asia. Let's see where we can squeeze these other ones in. 25 degrees. Oh, let's see. I might have given myself some trouble here trying to squeeze these in, but that 25 degrees, the 7%, that's Europe. Okay. 57 degrees. So let's think about this for a second. And again, this is all just visual. I'm not going to bust out a protractor and make sure your angles are correct. Really, I'll be looking for your math here. So if you can get this part correct, you're okay. This was 104 degrees, right? So there'd be 76 degrees here total. Okay. I took off 25 degrees, which leaves me with about 50 degrees left over. Oh, these are both equally away from 50. I'm going to just go ahead and call this one my 57-degree angle-ish. That's my 16%, so that's North America. Okay. And then I'm going to go 22 degrees off of Asia, and that is Australia. And 43 degrees would be my last one, my South America. Okay. And so that's really what I would be looking for. And it's totally just visual. It's totally just estimation. Really, should I make you take out a protractor and measure those angles and make sure they're correct? Sure. But like I said, I don't think there's ever going to be a time when you actually have to do that by hand. Okay, we have software that will do this for us now. What's important for you to understand is how these numbers become percentages and then how those percentages become degree measures. And so that's what you're kind of responsible for. Okay. Now, let's take a look at that last question. It says if the area of the continents was measured in kilometers or square kilometers instead, how would the graph change? Really, it shouldn't change at all because the purpose of this graph is not to show me how many square miles something actually is. It's to show me, for example, how does Asia compare to North America? And so if I change all of the measurement system, those proportions, those comparisons are still going to be the same, right? So my graph would not change one bit if I change this thing to square kilometers. These numbers would change, but when I go to turn them into percentages, the percentages would stay exactly the same. Now, if I did a separate graph for population, that might look very different because that total population is going to be something completely different. The percentages are going to be different and so on. So for example, you know, this Antarctica is 9% of the total land mass out there, but I would bet that that's not 9% of the entire world's population. So those percentages are not necessarily going to line up in that case. Okay, that's really it for the first lesson. I think the biggest thing in the first lesson is just all of that vocabulary. This is really kind of a tiny piece. I know we spent a lot of time on it, but this is really a pretty small piece of this lesson. If you have questions, feel free to jump in and ask in class. Otherwise, you can go ahead and get started on your homework.